Alright everybody, welcome to the video for the examples for parallelograms and rhombi, which is the plural of rhombus. It's a weird sounding word, but sorry about that. So, parallelograms, we want to find these indicated measures in this shape that we know is a parallelogram, and what we're going to need to do is we're going to need to use some of the properties that we learned about of parallelograms to be able to do so. So first thing we want to do is we want to find HI. Find the indicated measure. So how big HI is. Well, here's HI over here. We see it's this side. And remember, one of the properties of parallelograms is that opposite sides are congruent. So we know that KJ, the opposite side, is 16. And that tells us that HI will also be 16 in length. Next, we want to find GH. Where is GH? There it is. So we have GH here. Another property of parallelograms is that we know that diagonals are bisecting each other. So in the middle is G, and we know that that length is going to be the same as the other half. So one of them is 8. The other one will also be 8. And then, since we know that GH is 8, if we want the whole length of HG, that whole diagonal, 8 plus 8 is 16. So next we want some angles, and we have KIH. So we want this one here. KIH, right there. That's the angle that we're looking for. One thing to keep in mind with these problems is that these are taking place in the constraints of parallel lines. So sometimes what you're going to notice is that you have alternate interior angles going on. We have this angle here, which is 28, which is an alternate interior angle to HIK. Alternate interior angles are always congruent, so we know that this here is 28 degrees. If we want JIH, where's J? There it is. So JIH, we want this whole angle now. One thing you can think about is up here. Let me erase some of what we have here. One thing that we know is that, and it looks a little deceptive, see how this symbol is here? This whole thing is 84 degrees. So what we can do is, if we want to find this angle here, remember, angles that are next to each other, like this one and this one, are supplementary in parallelograms. So if we do 180 equals 84 plus the missing angle, we'll figure it out. Minus 84, minus 84, and we get 96 equals x. So JIH is 96 degrees. Last one we're looking for here is HKI. That would be this one here. Well, so we're looking for this one. We know because of alternate interior angles that it'll be the same as this one. And we know that all of this angle here is 96 degrees. We know that this little half one here is 28 degrees from an earlier part of the problem. I'm sorry, not this part, but that part over there. So we know that part of it is 28. We know that part is 96, or the whole thing is 96. If we do 96 minus 28, we're going to get 68 degrees, which is the part that's missing right here. And then using alternate interior angles, we know that this is also 68 degrees. So that's using the parallelogram properties a little bit. For rhombus ones, let's go to the other side, and we're actually going to skip the section that's right there, and we're going to go directly to the next one about rhombi, which is right here. Okay, so the diagonals of rhombus ABCD intersect at point E. given that the measure of BAC, it's already labeled in here for you, is 53, and DE is 8, let's find everything else that we want. So, first thing we're going to find is DAC, which is this angle here. Remember that in a diagonal, the angles are bisected by the diagonals. In a rhombus, the angles are bisected by diagonals. So if 1/2 is 53...
Carly, could you please go to the greeter station? Carly Happy, to the greeter station.
The other half is also going to be 53 degrees. Next, we're looking for AED. Remember that in a rhombus, the diagonals are perpendicular to each other. So 90-degree angles forming at the middle. AED then has to be 90 degrees. And, okay, so what that means is we know that each of these angles, like this whole thing up here, is 53 plus 53, which is 106 degrees. That means that this angle here has to be supplementary to it because this is a parallelogram type. So 180 minus 106 is 74, which means that that whole angle there is 74 degrees, and that's what ADC is. So 74 degrees there. All right, let's clean the picture up just a little bit to find our sides that we want. So DB, since this is a parallelogram and half of the parallelogram, rhombus is a type of parallelogram, is 8, the other half will also be 8. So that's DB's length. I'm sorry, that is EB's length. DB then, the whole thing, has a length of 16. So that's good to know. Now, we're being asked to find what AE is. So, we're going to have to think a little bit about what it is that we want to do to find out that length. I'm usually going to give you some sort of measure to help you out here. You may have to use Pythagorean theorem at some point, but that would be possible. For example, one thing I could do is, and I'm adding this because I don't think that this showed up in the problem, but it should have. Let's say that we knew that AD had a length of 10. Since we know that this is a right angle, we could set up Pythagorean theorem to say that 10 squared, since that's the hypotenuse, equals 8 squared plus AE squared. That would be 100 equals 64 plus AE squared. You would subtract 64 from both sides and get 36 equals AE squared. Take the square root of both, and you'll find out that AE has a length of 6. So that would be something that you may be expected to do in a problem like this. Once you know that AE is 6, though, and since the diagonals are bisecting each other, you automatically know that AC has to be 12. So those are some examples of how these properties are being used. Check back again for further notes on quadrilaterals, different types. Thanks for watching.